Hello and welcome to this GLOBE Claritas video presentation, What's New in version 6.6. Version 6.6 was released to clients on the 29th of June 2017. I would first like to discuss some improvements we've made to a couple of the imaging suite applications. The first one I will talk about is Image K3T. We have recently been given access to a 40-core desktop workstation. This dual CPU desktop has 20 cores per CPU. Previously we had not encountered sort of a high core count chipsets like these with our applications, and we noticed that the runtimes being delivered by the K3T module using this architecture was not what we expected. As such, we took the time to review the code, look at how we could improve the runtimes and what could be done to optimize for this high core count CPU architecture. Consequently, the work that was done and carried out enabled us to optimize such that the runtimes on these CPUs is now 17 times faster than we had previously experienced. So we're quite pleased with that improvement and look forward to our clients testing and letting us know how effective the upgrade has been for them. I'll now move on to the other imaging suite application that we worked on this last release, and that's the SRME 3D multiple modeling application. Again, when we started looking at this with different data sets and stuff, we decided that the runtimes were not what we expected from the application. And it became apparent that during the initial development, we had somewhat optimized for the data set that we'd been provided for testing. And it was also apparent that although we'd given users control of cores, etc., to allow them to optimize for their architecture, the tests that needed to be run would be very complex, very long, and consequently challenging for users to be able to optimize effectively in time frames that they would want. So we took the decision at this point to see if we could set the application up so that it effectively self-optimized. This has meant we've removed some of the parameters from the form and simplified the form for users basically. So now basically what you need to do is when you set the application to run on a data set is provide it with the maximum number of cores you wish to use. There may be some benefit also in reserving a certain portion of the RAM available on the machine for other processes, and then allow the application to run. And whilst it runs, the application will look at how effectively it is using the RAM available, and if necessary, will adjust how many shots it's holding in the buffer and decrease that if required. So initially it will decrease the buffer size. If it still is having problems with optimal use of RAM, it will then sort of drop cores out. So it'll basically look at dropping a few cores out of the application. So if you tell it 40 cores, it may over time run down to be running on 36 cores to optimize RAM usage. So hopefully it will basically optimize itself for its use of RAM such that the process runs most efficiently on the data set. The other thing to bear in mind with the SRME application is that if you are using or running this application across multiple machines rather than just within a single desktop environment, then basically you should look to run the application such that you have the same number of input data sets as physical machines you're using in the cluster. So i.e. if you've only got a single input data set, then run that on a single machine. If you've got 2, 3, 4, 6, then you can run that on 1 or 2 machines, 2 or 4 or whatever, to optimize the throughput and runtime. So that sort of covers what I want to talk to you about, the improvements to the imaging suite in terms of run times, etc. I now basically talk you through the new Noise QC module, which we've added as part of the v6.6 release. So the Noise QC module is there to create a bunch of typical standard QC headers that users will want to use to confirm and check that their data looks good, or to pick bad shots, channels or traces. So there are three mandatory parameters, which are the max fold of the gathers you're providing, the time window for the RMS, and the noise time window. Optional parameters include specific windows for the peak amplitude and signal, which can be supplied and specified separately by the users. If they're left blank, then they use the same window as the RMS time window. The add time parameter is there and works the same as in all other Claritas modules, i.e. adding a value specified by the user to the time windows supplied. The VLMO parameter allows you to apply a LMO velocity to the data to flatten on, and then your RMS, peak, signal, noise time windows will be defined based on that LMO correction. And then there's also the option or possibility to store the gates defined into the trace headers as well. The Noise QC module has been created to work alongside the aerial and condor applications, which will be used to display the headers created by this module. I'll basically show you this firstly using the aerial application. And so aerial can be launched either from the miscellaneous tab of the Claritas launcher, or can be selected in a similar fashion to SV and size view by highlighting the data sets in SizeCat that you want to launch in aerial, and then select trace header cross plot brackets aerial. You can see there's also a new one, trace header map view cross plot brackets condor. I'll open this up. So firstly, we come up with a parameter form where we select the trace header we wish to display and the axes in which we want to plot them. So in this case, I will select shot ID and channel and the RMS amplitude window. And that then launches the aerial application. And as you can see, there are two panels because I opened two data sets and I can toggle between those. And I can basically, from the parameters form, I can select aerial display parameters and specify that I want a separate color bar for each panel. Click OK and apply and close that. And now you can see that basically the RMS amplitude window color bars change with the different panels. I can also select a different color scale or color bar to be used. So as you can see, I've swapped a similar fashion as used in the XView, SV and size view applications to change the color bar you want to use. You can also see that for aerial we've improved the annotation. So channel is here annotated top to bottom on the left hand side, and shot ID is annotated across the top. Previously there was no annotation in terms of shot ID and channel on the aerial window, which was less than optimal. As well as the improvements to the annotations along the side and across the top of the plot, we also now annotate the dataset and header being displayed in the aerial application. We can, as well as we can in XView and size view, update this trace annotation with something more to our requirements or preference. I.e., if we need to send something out to a client or save something for later use in a report via PowerPoint, we can provide header annotation in this graphic here that is more useful for that eventuality. As with size view, etc., we can also now create a PowerPoint display and save out the PowerPoint presentation for later use or sending out. We can also at any given point either read in a new data set, so we don't have to exit the aerial application to read in a new data set, or change the headers we're displaying, or add another panel to the display. So in this case, I will add another panel to the display and I will select peak amplitude, and this will read in the peak amplitude header from the GNS Job 1 HDF5 dataset and add that panel to the display. Then if I highlight panel 2 and carry out the same process, it will add the peak amplitude header from that GNS Job 2 dataset as well. So you can now see that we have 4 panels from these pre-computed QCs from the Noise QC module. We can also basically display any other trace header against any combination of trace headers. So if I select add another panel, rather than these pre-computed ones, I could go down and select the offset header and display that again, displayed against shot ID and channel. And you can see that brings up, adds another panel, and I've now got 5, one of which is the offset header. If I wanted to change this panel to something else, I could also go into one of these selections and select a different trace header to display. As I'm sure you're aware, Aerial also has the capability to pick bad shots, channels, or traces. And this capability still exists in the application. So if I click Set, this will allow me to select a single bad trace wherever I see them. If I select Set Row, then I can pick a bad or weak channel and kill all those. And if I select Set Column, I can select a bad shot or shots to kill. The change between how Aerial used to work on the .are files and how it works on HDF5 files is, rather than having to write out a .tre file that we then need to read into a job flow and apply to the data, when we're using Aerial on an HDF5 file, when we pick a bad shot edit, for instance, then the TR types of that picked bad shot are updated in the HDF5 trace header, and effectively the kill is applied on the fly to the dataset. Obviously, if you make a mistake and kill some shots that you don't want to kill, rather than having to go through and use the clear column capability, if the number of edits is such that you think it's going to be easier to start from scratch, we can go up to the File menu and select either Restore Initial HDF5 TR types for the panel you're on, or for all panels that you're displaying, and you get back to the point you started from. So there's a lot of new capability within the Aerial application. The aim of this has been to basically make the user's life easier by removing the necessity to apply edits in a job flow, This makes life simpler because it cuts down on the number of job flows you might have to run. It also means that you're unlikely to apply the wrong set of trace edits to a data set, i.e. pick up trace edits for line 10 when you wanted to apply trace edits for line 1. So again, makes life a lot easier for the user because there's less chance for an error to be made. I will exit out of the aerial application, and we can now look at the Condor application. Condor is available from the Geometry tab of the launcher, or again, as with Aerial, from right mouse button click and selecting Trace Header Map View Crossplot Condor. I will run this from the launcher. I'll click on the Condor application, and it brings up a blank Condor map interface for the view to look at. Click on the File option and Open, and I'll select the Noise QC HDF5 dataset. So the default behavior for Condor is to bring up and display source and receiver pegs by elevation on the display. Once you've got this display up, we can then look at other things as we want to. So you can see there's tabs down the side for display properties, so we can change some of the display properties, color bar information, map view. So this allows us to do some simple geometry QCs in the Condor application. So in this case, if I click on display trace midpoints and OK, it will calculate the trace midpoints on the fly and display them on the screen. One of the other advantages of Condor is that we can easily zoom in and out with the plus and minus buttons, and this is all very quick, or using the middle mouse wheel to zoom in and out. Next tab down is for quick crossplot. So this allows us to display the pre-configured headers, so the RMS amplitude, peak amplitude, noise QC, and if applicable, the data fold. So we click on there and select the header we want to display, RMS amplitude, and what we want to display that against, in this case channel shot ID. And again, allow it to go away, calculate and do its stuff, and display that on the screen. And again, like the aerial application, we can also do a more customized crossplot. So select any particular trace header we have. So in this case, we will go and select the offset header. We can either display it based on predefined axes headers, crossline, inline, channel, shot ID, etc. Or if we selected custom axes, we can then define the trace headers we want to plot this header against. If I click OK, it will then bring up and display the offsets within each shot on this panel. And again, as you see, it's relatively simple and fast to zoom in and out on this application. We've developed similar functionality in both Aerial and Condor so that we didn't orphan our current users who are on older operating systems and not give them access to this functionality. We had to do this because the plotting library that we needed to use in Condor was not supported on older operating systems because of the versions of Python they were running. For instance, this is CentOS 6, Red Hat 6 OSs. You will be needing to use the Aerial application rather than Condor. People on CentOS 7 or the Ubuntu operating systems can use Condor. Now, Condor doesn't yet have all the functionality that exists in the Aerial application. For instance, there's no capability for multiple panel display, and we can't pick shot and channel edits at present. This functionality will be incorporated into the Condor application during future releases. So that's all I want to say about the Condor application. So I'll close this down and then basically show you some of the other improvements we've had in the software. So I'll start with showing the new project selection widget. This has been created using Qt. Has a lot more functionality than the old application. So for instance, it now displays all the projects that exist within the user's registry or the company's shared registry. The first 5 projects displayed in the widget are those most recently used by the user or users. And then everything else is listed in an alphanumeric order. So one of the new capabilities within this application is the ability to filter on any of the columns listed up there. So I could basically put in 3D and it will extract any of the projects that either have 3D in the project, owner, testing or site, and or the description of the project. And I can get rid of the filter once I no longer require it to be there. I can also click on the No Project button and set up to work the launcher in a non-project environment. So very simple, easy to use interface and provides a lot more functionality than the old Xwin X11 interface used to do. Finally, the last piece of improvement to the software that I will cover in this video is some improvements to the auto pick functionality in the SV application. So if I bring up a set of shots, in this case the Land 2D Tutorials Line 04 Geometry Applied Shots, click on the auto pick, dismiss the first window, and say, so in the approximate pick method now we have 2 additional options for this capability, and these are envelope threshold or using a pre-existing pick file. So if we leave it initially on the envelope threshold option and click OK, you can see it comes up with 2 parameters, an initial envelope threshold, the high threshold value, and a balance window. So the balance windows and thresholds here are usually larger than those used in the main pick method when we use envelope threshold, and longer with balance windows. If we click OK, you can see the picks come in and they're pretty well, pretty good set of picks for that first pick method. Obviously, apart from where we have this high noise area, we can adjust both the high threshold used by clicking on the plus minus buttons when we've selected envelope high threshold, or the balance window as well. So this is a different option. I mean, I think typically we suggest or recommend using LMO as that sort of approximate pick method. That's fine where a single velocity provides a reasonable approximation for your data set. Often within a shot or within the line, that sort of optimal LMO velocity will vary because of changes to the weathering layer. So we're sort of seeing that the envelope threshold option provides a suitable alternative, particularly on datasets where that sort of LMO velocity is likely to vary either within a shot because of change in weathering layers or across the line itself. Once you've got your what you feel are optimal parameters for that envelope threshold first pick option, you can then add in main picks, etc., to refine those picks down as required. If I middle mouse button click on the auto pick and then show you the other option, which is to use a pre-existing pick file, click OK, it'll then come up and ask you for the pick file you want to use. So the idea here is that you've picked your line, got yourself what you thought were quite good set of first break picks within SV manually or auto picking. You've come out, QC'd them in RefStat and been a little unhappy with what you've got. You can then take those first pick in, set of picks in as a seed for your update, and basically have your approximate pick method be those initial picks, and then refine those picks based on the main pick methods, etc. So hopefully improve them and refine them down to a better set of picks to input to RefStat. So that concludes this video on what's new in v6.6. If you have any questions about Claritas or the new release, please don't hesitate to contact us on claritas.support@gns.cri.nz. Thank you for your time, and goodbye.